Hello everybody, welcome to the lecture 2 video of Python for Data Science. I am Dr. Dilek Celik. Today we are going to looking at the branching, decision making. We will be looking at how we can get an input from the user. Then we are going to be looking at the operators used in Python. So branching, and basically guys, we have Python has if-elif-else, shorthand if-else, nested if-elif-else for decision making. And we are going to be looking at each of those with detail and how we can use them in decision making. So Python supports the usual logical conditions from the mathematics, such as the A equals B or A smaller than B. And these conditions can be used in several ways, and most commonly if statements and some loops. And we are using the if statement in Python to check the conditions. So first of all, you need to write the if, then you need to put your conditions here, and at the end you have to use the colon. And any statements that will be executed after if statement should be inserted with an indentation after the if statement. So if this condition is true, then this piece of line, this line of code will be executed. Then the next line of code will be executed. And as the x equals 15 in this example, and x is greater than 5, this will be printed, then this will be printed. And when we run this piece of code, and this is the result we will get, as you expect. Yes, we use the Python. In Python, we use the if keyword to check for the conditions. And if the condition is true, the conditional code is executed. If the condition is false, the next line of code is executed in Python. An indentation block is one of the most important parts of the conditions. And indentation basically is the white space at the beginning of line of code. And you can do this indentation with a tab, or it equals to 4 character spaces. And the whole idea, the main idea behind the indentation is to clearly define where a block of control starts and ends. And all the lines of code that should be executed when the if condition is true should be within the indented block. Let's look at this with more detail on this example here. We have two variables, x equals 12, y equals 8. Then we have if statement here, if x is greater than y, this is a condition, then we have the colon. If this condition is true, then the line of the code, which is presented with indented block here, will be executed. If this condition is true, this will be executed. If this condition is false, the next line of code will be executed. And as the x greater than y in this case, then it will print x is greater, then it will print done. So when you run this piece of code, and this is the result you will get. The if statement should always be followed by code block. There should be an indentation of that code block. Otherwise, the system will complain about it. So if you run this piece of code here, guys, and the system will tell you that the unexpected, an indented block. So you have to insert by a code of block with an indentation at the beginning after the if statement. Otherwise, the system will complain about it. It's not gonna work. And in Python, the programs get really interesting when we test conditions and when we change the program behavior depending on the outcome of the test. And there are several comparison operators. logical operators and Boolean expression and values in Python. And comparison operators, guys, and those are some comparison operators. So let's look at them with more detail here. X equals Y. This will produce true if X is equal to Y. Then we have another comparison operator, X is not equal to Y. If this condition is true, so this will produce true if X is not equal to Y. And this will produce true if X is greater than Y. Then we have X smaller than Y. If this will produce true if X is less than Y. This will produce true if X is greater or equal to Y. And again, this will also produce true if X is less than or equal to Y. So those are some comparison operators. And then we have some logical operators. Sometimes you might have more than one conditions. In those kind of cases, you can use some logical operators, and they are and or not. And also we have Boolean expressions, and they basically Boolean expression evaluates to produce a result, which is a Boolean value. And the Boolean value, as you remember, it can be either true or false. So when you have multiple conditions, you can use logical operators. And with the use of logical operators, it is possible to combine multiple comparisons together in a conditional expression. Let's look at those examples here. Let's look at this one. We have three variables defined as x equals 8, y equals 9, z equals to 10. And as you can see, we have if statement, and then we have two conditions here. Z is greater than x, and means that the both of the conditions must be provided so that we can execute this line of code with an indentation block here. If any of this is not correct, if any of this condition is false, then this will not be executed. So when you run this piece of code, and this is the result you will get, Z is greater. Let's look at another example here. In this case, we have the use of OR, as you can see here. In this case, it is asking again, Z is greater than X, and Z is greater than Y. And as the both of them are true, therefore it will print Z is greater than X or Y. And finally, we have not. And basically, not shows the opposite of the result. And we have two variables here, x equals 8, y equals 9. X is greater than y. So this condition here is false. As this is not, right? And therefore, this condition becomes true. Therefore, this line of code will be executed here. Therefore, it will say that x is not greater than y. So in here, guys, we are checking if x is not greater than y. So this makes the opposite of the condition. And also we have else keyword in that we can use with the if. And else keyword catches anything which isn't caught by the preceding conditions. So let's look at the else keyword on an example here. As you can see, we have if and else here. We have x and y values, x equals 15, y equals 20. So in here we have a condition if x is greater than y. If this condition is true, if this is true, this will be executed here. If this condition is not true, if this condition is false, then in other conditions, the anything you have inserted here will be printed out. Right? Basically, else keyword will be catching anything which isn't caught by the if statement, by the if condition here. So in this example, it will say that y is greater because x is smaller than y. Therefore, this condition becomes false. Then it goes to the next line of code here, which is the else statement. Then it prints y is greater. And also we have elif keyword, and we use the elif keyword when we want to do some chained conditions. In some conditions, there are more than two possibilities, and we need more than two branches. And one way to do this is by using a chained conditional, by using the elif keyword. And the elif basically is an abbreviation of else if. And there is no limit on the number of the elif statements that you can use in any condition. So, however, when you are using the elif statement, the final else statement is allowed, and it must be the last branches in the statement with the elif, with the use of elif. So let's look at this example here, guys. We have the mark of the student, which equals to 80. And when you want to categorize them as distinction, as good, pass, or fail, and basically to put any group, to put this mark into any group, you can use if, elif, and else, if, elif, and else branches together. So how we can do this is that, first of all, you have to check if the mark is above the 70 and it is less than 100. So equal or greater or equal to 70 and smaller equal to 100, it will say distinction. So if the mark falls into this area, then it will print distinction. If not, we have another condition here, if mark is smaller than 70 and mark is greater or equal to 60, we would like to say good. If this is not the case, then we will have another condition here. If the mark is less than 60 and the mark is greater or equal to 50, in this case, the pass will be printed. And if any of these conditions are not provided, then the else statement will be executed here, and then it will say fail to the student's mark. When we run this piece of code, it will say distinction. Because the mark is 80, therefore it falls into this area, and therefore it prints distinction. So this is how you can use if, elif, else keyword altogether. This is a summary of if, elif, else statements. So first of all, you should have a first condition, and this will be executed if the condition is true. Those statements will be executed if this condition is true. If this condition is false, then it will go and check for another condition. Then these statements will be executed if this condition is true. If this condition is false, then it will go to else. So basically then those statements, anything you put here under the else statement will be executed if the conditions, above conditions, are not true. So this is how if, elif, else statements work together. And how many elif and else for an if block? An if block can have only one if block, 0 or more elif blocks, 0 or 1 else block. So basically you can use if block by itself. And else and elif are used as needed, and they are optional. So you can have the if without else and elif. It is possible to have an else without an elif, and also it is possible to have an elif without an else. And also we have shorthand if. It is possible to write an if statement in one line and when there is no elif and no else in Python. So let's look at it on this example. As you can see, we have two variables here, a equals 20, b equals 20, and then we have if statement, then we have to provide the condition here, then the colon. Then you have to put your statement here. Anything you put here will be printed if the condition is true, right? This is your condition, then the colon, then the statement. When you run this piece of code, as the a and b are equal, then it will print a and b are equal here. This is how you can write the if statement in one line. And also it is possible to use if-else in one line. So let's look at this example here. We have a equals 2, b equals 330. In this case, guys, we have to write the statement of the if first. This is the statement. This is a statement of if. So if the condition is true, if this condition is true, then this will be executed. If this condition is false, then if this is false, this will be executed. So else, the statement of else will be executed. So as the a equals 2 and b equals 230, therefore a is not greater than b, then this line of code will produce b. So this will be the result you will get if you run this piece of code here. Also, we have nested if, elif, and else. So basically, guys, you can use another if inside the if, and we call this as nested, right? So let's look at this example here. So first of all, you need to write an if, then you need to have a condition, right? Expression. Then if this condition is true, this statement will be executed. And also you can have another if inside this, under this if statement. As you can see, you have to put indentation. It means that they are inside the if statement. So this will be executed, then all this will be executed, then the other codes will be executed if this condition is false, then the elif. If this condition is false, then the else will be executed. So basically, nested if, elif, else means that when you use another if inside the if statement, and we call this as nested. Now we will be looking at an example of the nested if, elif, and else. An extensive use of nested if, elif, else statement is a bad programming practice because it will make your code difficult to read and maintain. And let's look at this example. This is a good example of the use of if, a nested if, elif, and else together. So in this example, it is asking user to insert an input. It is asking user for an input for a number. Then the system, the code, checks if the number can be divided by 2 and 5. So if the number can be divided by 2 and 5. And to solve this kind of problem, a nested if is used. So let's see how it has been used here. First of all, you have to check if the number can be divided by 0. And to do this, we use the modulo here. So when you do this one, guys, that equals to 0, it means that the number can be divided by 0. So if this condition is true, then we have another if here, and then it is checking for if the number can be divided by 5. And if this is true as well, then it will say that the number can be divided by 5 and 2. If this is false, if the number cannot be divided by 5, then it will print the number can be divided by 2, but not divided by 5. And we have else here. This is the else for the if here, guys. And if the number cannot be divided by this 2, then it will go and check if the number can be divided by 5 only. Then if so, it will say that the number is divisible by 5, but not divisible by 2. If number cannot be divided by 5, then it will say that the number cannot be divided by 2 or 5. So this is how you can use nested if, elif, and else together. So when I run this piece of code, I entered number 10. Then as the 10 can be divided by 5 and 2, then it produces that the divisible by 5 and 2. In Python, we can ask user for an input using the input function. So this is how we can get an input from the user. Sometimes you need to ask user for an input, and the user can do it. And you should include this function in your program so that you can ask user to input, and you can use that input in your code. And when the input function is called, the program flow will be stopped, and the user has given an input. Then the user has to enter, click on the enter so that the program continues to execute. And these inputs are stored in variables and used to run the program. So let's look at this example here. And we have defined a variable. This is a variable, right? We use this to hold the input. And when we say this variable equals to input, basically this will ask user to enter an input. Then we can use this variable that holds the user's input inside the code. So for example, we can print it out here. And when we run this piece of code, and it will ask user to enter a value, then I entered my name, then it tell me that you entered Dilek, because we said that. So this piece of code is executed and it returns back the value that I have entered. We can add a prompt message to the input, and the input displays this prompt message, displays it as a prompt to the users before pausing to read it. So for example, we have a variable to hold the input, then we ask users for an input. Then we have a prompt message. Basically, this will be shown to the users. The users will be seeing that enter a value, then the user will enter a value. And here we print out the user's input. When we run this piece of code, it will ask user, it will be showing user this one, enter a value, right? Then I entered my last name, which is Celik. Then it returned me back, you entered Celik. So this is how you can get an input from the users, and this is how you can use it inside your code. An input accepts strings by default. Anything you enter as an input, the input function basically converts into a string. Even though you enter a numeric value, the input function will still convert it into a string. And because of this, you have to explicitly convert the numbers, numeric values, into integer using the typecasting. So we'll learn about typecasting in the lecture 1 video, and you can go and watch that one if you don't know about typecasting. So let's look at those examples here. And in the first one, we are asking users for an input. Then we store the input in the my input variable here. Then we return back, we print the input here. In another example, again, we are asking users for an input. And in this case, guys, as you can see, when we are printing, we are making an addition of it, 20 plus my input. If the user enters number here, let's say that the user entered 20, and normally, guys, this will be treated as a string. Because we make a typecasting here, basically we are changing the type of this input to integer. Therefore, we will be able to make the calculation in here. Otherwise, the system will complain about it. And when we run this piece of code here, guys, so when I enter 40 to the second input, right, then it returns me the total of 20 plus my input. As my input was 40, then it returns 60. So this is what you need to do when you wanna get some numeric value from the users. You have to use typecasting. Okay, you have to use. This is what you need to do when you wanna get some numeric values from the users. And it is also possible to get multiple inputs at a one time from the users using the split function in Python. And the split function, basically, it splits the values the user entered based on the space between those values. And how we can use this is that, and if you, for example, if you want to get a 3 input from the users, okay, let's say that you want to get 3 inputs from the users, and you should define through 3 variables name, then you need to say input. This is the prompt message, right? Enter 3 values. Then at the end of this, you have to use a split like that, so that the split function here will be splitting the numbers the user entered based on the spaces. So when I run this piece of code, and basically it is asking me to enter 3 values, and I entered those numbers. Then the system splits them, and the A becomes 40, and B becomes 27, and C becomes 13. Then it prints them all in these sections. Therefore, it will produce these results for us. So this is how you can insert, how you can enter multiple inputs at one time using this split function. And there are Python operators, and the Python operators can be classified into arithmetic operators, comparison operators, assignment operators, logical operators, bitwise operators, membership operators, and identity operators. And now we will be looking at each of them with more detail. Let's start with the arithmetic or mathematical operators. And basically, they are used to perform mathematical operations on operands. And those are the arithmetic operators, as you can see here. I'm going to demonstrate them on an example. So I assume that I have 2 variables, x equals 30 and y equals to 10. And I will demonstrate them all here. So first of all, we have an addition operator. It adds the x to y. And when you look at this example here, x plus y, and it equals to 40. Then we have a subtraction. It subtracts the x from the y, and x minus y equals to 20 on this example. And then we have multiplication. This multiplies x with y. X multiplied by y equals to 300 when we consider this example here. Then we have a division. This divides the x by y. X divided by y equals to 3 on this example. Then we have the modulus, and basically this will be returning the remainder of the division of x by the y. And x modulus y equals to 0. Then we have exponentiation. This perform exponential, the power calculation on the operators. X exponentiation y will equal to this value here. Then finally, we have a floor division, and this returns the quotient in which the digits after the decimal point are removed. And x floor division y will equal to 3 on this example. So this is how we can use the arithmetic operators in Python. And we have been provided some examples here. We have three variables, x equals to 15, y equals to 10, z equals to 0. And this is also another way of defining the variables, guys. You can define your variables in this way in a one line as well. And we have the addition, we have subtraction here, we have multiplication, we have a division here, then we have a modulus here, we have exponentiation, and finally we have a floor division example here. And when you run this piece of code, and those are the results that you are going to get, and you can try this on your computer as well. Then we have comparison operators, and those are also relational operators. Now I will show you how we can use them on these examples. I have two variables, a equals to 20, b equals to 30. And I will demonstrate these examples. I will demonstrate these operators using these values. First of all, we have equal value, equal operator. And if the values of two operands are equal, then the condition becomes true. So when we consider these examples, these values here, a equals b is not true because a is not equal to b, right? 20 is not equal to 30. And then we have another condition, not equal. If the values of two operands are not equal, then the condition becomes true. So when we say a not equal to b, then this will produce true for this example here. Then greater than, if the value of the left operand is greater than the value of the right operand, then the condition becomes true. A is greater than b is not true because a is smaller than b. Then we have a less than. If the value of the left operand is less than the value of the right operand, then the condition becomes true. A smaller than b will be true in this case. Then we have greater than or equal to operator. If the value of the left operand is greater than or equal to the value of the right operand, then the condition becomes true. And this will produce us this will not be true as a is smaller than b. Then we have less than or equal to operator. And if the value of the left operand is less than or equal to the value of the right operand, then the condition becomes true. When we say a less than or equal to b, this will produce true for us. Let's look at them on this example here. Basically, we have all these operators. We have equal, we have not equal, less than, greater than, less than or equal to, greater than or equal to. We have two variables, a equals to 30, b equals to 10. And when we run this piece of code, a equals to b, this will produce false. A is not equal to b, this will produce true. A is smaller than b, this will produce false. A is greater than b, that's true. A is less than or equal to b, this is not true, therefore it is false. A is greater than or equal to b, that is true. And when you run this piece of code, and as you can see, those are the results you will get. And as you can see, those results are aligning with our outcomes here. And there is a common pitfall. The Python is dynamic and stronger typed language. So if two variables x and y or a and b have the same values, but they are different types, then the a and b are not equal. So let's look at this example here. We have a equals to 30, b equals to 30. However, as you can see, this has been assigned with the quotes here. Therefore, the type of this is a string, and this is an integer. As their types are different, and therefore they are not equal. Therefore, this will produce false to us. When you run this piece of code, and this is the result you will get, this will produce false because A is string and B is an integer. So let's look at assignment operators. So basically, guys, we use those operators to assign the values from one side to another. And first of all, we have the equal operator. And this assigns the values from right side operand to the left side operand. So for example, C equals A plus B assigns the value of A plus B into C. Then we have the plus equal. It adds the right operand to the left operand and assign the result to the left operand. So C plus equals A is equivalent to C equals C plus A. I think this is one of the common way that we use in Python. So you must learn those operators, how we can use those operators. So those are the quick and easiest way of using some addition of those values. And we have a subtraction. Basically, this operator subtracts the right operand from the left operand and assign the result to the left operand. Same as C minus equal A is equivalent to C equal C minus A. Then we have multiplication equal. It multiplies the right operand with the left operand and assign the result to the left operand. C multiplied equal A is equivalent to C equals C multiplied by A. In the same way, guys, we have the divide, we have the division, we have the modulus, we have the exponentiation, and finally we have the floor division. In all of them, guys, basically the operation has been done with the right operand, then the result is assigned to the left operand. And you have been provided an examples of them here. And as you can see, we have three variables, A equals to 10, B equals to 6, and C equals to 0 here. And first of all, we have an addition here. C equals A plus B. It means that the C equals 16. Then we have C plus equals A. It means that we need to add the A on top of the C. As the C is 16, right? As the C is 16, we need to add A on top of C. Therefore, this will become, C becomes 26 here. Then we have C multiplied by A. So basically, we have to multiply the 26 by the 10 here. Then this value, the C value will become 260. And then we have C divided and equal to A. And here, guys, we have to divide the C by an A, and therefore the result will be 26. And as you can see, we have a redefined C here, and C equals to 3. And then we have the modulus here. C modulus equals to A. So 3 modulus equals to 10. So this will produce 3 for us. Then we have this C exponentiation equal to A. Basically, this will be the result of this one, right? And finally, we have the C floor division equal to A, and the result of this will be produced here. When we run this piece of code here, guys, and those are the results you will get. As you can see, the results are aligned with our findings here. So this is how these assignment operators work. You can try them. You can stop the video here. You can just go and try each of them one by one, just to better understand it. Then we have logical operators. We have truth tables. A truth table basically has one column for each input variable and the final column showing all the possible results of logical operation that the table represents. And in the truth tables, guys, we have the P and Q values. And basically, those are the hypotheses, right? Those are some assumptions or statements. And they can be either true or false. And there are two possibilities. They can be either true or false. And the truth tables are created based on them. And T stands for true, and F stands for false in the truth tables. So let's look at those examples here. We have P, right? This hypothesis. And one of the possibilities is that it might be true or it might be false. And not P means that the reverse of this result. If it is not true, then it is a false. If it is not false, then it is a true, right? This is a logical NOT, basically. And we have a logical AND, and true and true equals to true. True and false is false. False and false is false. False and true is false. So those are something that you need to learn. And we have logical truth table for logical OR. True or true is true. True or false is true. False or false is false. False or true is true. So this is how the logical OR is used. And the logical operators operate on logical values, and we have AND, OR, and NOT logical operators, as we already look at in the previous slide. And the AND returns true if the both statements are true, and OR returns true if the one of the statement is true, and NOT reverse the result, that returns false if the result is true. Let's look at this example here. We have X and Y. X equals to true, Y equals to false. X and Y, true and false, will be false. X or Y, true or false, will be true. Not X is false because it is true. Not X means that you need to reverse the result, and it will be false. Not Y will be true. X and Y was false, as you remember, and not X and Y means that will produce true as well, because we need to reverse the result here. And when you run this piece of code, and these are the results you will get, and as you can see, they align with our answers here. And also there are bitwise operators, and bitwise operators performs bit by bit operations. And this is a truth table for binary XOR. And we have the P and we have the Q values 1, 1, and 0, 0, and 1, 0, 0, 1. And P or Q, when we look at here, guys, and 1 XOR 1 equals to 0, 1 XOR 0 equals to 1, 0 XOR 0 equals to 0, 0 XOR 1 equals to 1. And bitwise operators performs bit by bit operations, and they are used to compare the numbers. And so when we say X equals to 20 in binary format, the X equals to this value. And when we say Y in binary format and y equals to this number. And Python will convert the numbers into binary format, then performs the bitwise operation, then return the results in decimal. And there are some operators, those are some bitwise operators. There is an AND, there is OR, there is XOR, there is a NOT, there is shift left by n bits, and also there is shift right by n bits options that can be used in the bitwise operators. And then there is a membership operators, and they are used to test if a sequence is presented in an object. So, and they are in and not in. In returns true if the sequence with a specified value is present in the object. So for example, when we say x in y, if the x is in y, then this will produce true. Not in returns true if a sequence with specified values is not present in the object. X not in y will produce true if x is not in y. So let's look at those examples here. We have a equals to fourth, b equals to not. And we have a string here, which is fortunately, and we have the use of membership operator here, which is in. When we say a in my string, if the fourth is inside this, then it will produce true. And then we have the b not in my string. So if the b, which is not, as you can see, it is not in the string, then this will produce true as well, because b is not in my string here. And when you run this piece of code, then those are the results you will get. And there is identity operators. The identity operators are used to compare the objects, not if they are equal, but if they are actually the same object with the same memory location. And is will return true if both of the variables are the same object. So for example, when we say x is y, if they are the same objects, both variables are the same object, then it will produce true. And is not returns true if the both variables are not the same object. X is not y will return true if the values are not the same object. Let's look at those examples here. We have a and b, both of them are equals to 20, and we have the c value that equals to 40. When we say print a is b, as they are the same values, it will produce true. And then we have a is not c, as this is true because one of them is 20, the other one is 40, and this will also produce true for us. And when you run this piece of code, and those are the results you will get. Another important thing is the operator's precedence. The Python has well-defined rules for specifying the order in which the operators in an expression are evaluated when the expression has several operators. So for example, multiplication and division have higher precedence than the addition and subtraction, right? And those are the general rules in mathematics. And precedence rules can be overridden by explicit parentheses. So for example, since the multiplication has a higher precedence than the addition, and we can write them like that. So for example, a plus b multiplied by c, this can be treated as a plus parentheses b multiplied c parentheses close. And likewise, we have a multiplied by b plus c, and this can be treated as parentheses a multiplied by b parentheses close the parentheses here, then plus c. And those are the operators precedence, and the highest precedence at top, lowest at the bottom. So this is from the top to the bottom and from left to the right. So highest precedence at the top, the lowest at bottom, and operators in the same box evaluate from left to right. So when we look at here, guys, and those are the priorities, and so we do the first parenthesis, then the exponentiation, then complement, unary, plus and minus, and from left to right. So this is basically the operator's precedence table. And let's look at those examples here. We have been provided some operation, and let's see how they work here, some calculations here. And we have given 4 variables, a equals to 30, b equals to 20, c equals to 15, and d equals to 10. And in here, guys, in the first example, e equals to a plus b multiplied by c, and this can be treated as like that. So we can, because the multiplication has the precedence, right? It has to be done first, then the addition should be done here. In another example, we have a multiplied by b plus c, and here in again, the multiplication has to be done first, then the addition should be done because this has priority. And parenthesis has higher precedence. Let's look at this example here. We have a plus b, and this parenthesis has to be done first. The operation inside this parenthesis should be done first, then the multiplication, then the division here. In another example here, again, the parenthesis first, then the multiplication here, right? So then the multiplication here. In another example, we have the parentheses. This parenthesis should be done first, then the multiplication should be done next. In the final example, again, we have the parenthesis. This has to be done first, then the division should be done, then the addition should be done here on this example. And when you run this piece of code, and those are the results you will get, and you can try them all one by one on your computer. Just use a notebook and just go and try each of piece of code and write them one by one. Don't copy and paste the stuff. Just do it one by one, and just check the answers of each of them. Just try to understand it, how it works. Associativity of operators of the same priority. Sometimes, guys, the operators might have the same priority, and in this case we look at the associativity. And the associativity is the order in which an expression is evaluated that has multiple operators of the same precedence. And almost all operators with the same priority evaluate from left to right. So for example, let's look at those examples. In this example, we have left-right associativity. And when you have the operators that has the same precedence, like the float division and the multiplication here, and you start evaluating from left to the right, right? You do the multiplication first, and then you do the float division here. In another example, again, we have the operators with the expression with the same precedence. Then this has to be done first, and then the next one, from left to right. You will get the same results, right? This is how you can do it. Only the exponent operator has right to left associativity. So we have given an example of exponent operator here, and in here, guys, you start from right, then you go to the left. So this means that two exponentiation, right, two exponent operator, and so as the exponent of 2 exponent of 3 is 9, therefore this will be something like that, and then you have to calculate this, and the result will be 512. And when you run this piece of code, and those are the results you will get. So this is something that you need to know about it, the associativity of the operators of the same priority. Some operators, like assignment operators and comparison operators, don't have associativity in Python, and they are separate there are separate rules for sequences of this kind of operators, and they cannot be expressed as associativity. So let's look at those examples here. We have A less than B, B less than C. Neither means that the parenthesis A less than B, close the parenthesis, less than C, nor A less than parenthesis B less than C, close the parenthesis. So they mean the same thing. It is equivalent to A less than B and B less than C, and is evaluated from left to the right. So those are some non-associative operators that you need to know about it. This is the end of this lecture 2 video. Thanks for watching my video, guys. If you like my channel, please do subscribe to my channel. Do like my videos and do share my videos with your friends. Thanks for your support. See you in the next lecture video. Have a nice day and see you. Bye-bye.